Hi there, this is Mrs. Often, and this lesson is on composition of transformations in the coordinate plane. By the end of this slide deck or video, you will be able to perform compositions of transformations in the coordinate plane, and you will be able to use the function notation to determine what transformation you should be doing with a given set of points or a polygon. These transformations may include rotation, reflection, dilation, or translation. Remember that compositions of transformations may or may not produce isometries. Those which contain a dilation are unlikely to be isometries. I can't really ever think of a time where I had something that involved a dilation and it was an isometry, but if somebody's going to do a really boring dilation, like scale factor of 1, I guess you could get an isometry. Be sure to follow the composition in the order it is given. Doing it out of order may produce a different result. So let's begin with this. We are given our pre-image A00, B81, C55. That's going to produce a triangle in quadrant 1. And we're going to do a transformation that is a reflection, capital R, in the y-axis combined with a reflection of 180 degrees. So we're going to order our transformations and we're going to show the coordinates. So here's our original triangle. You can see A is at 0, 0, B is at 8, 1, and C is at 5, 5. So our new coordinates when I reflect in the y-axis are going to be as follows. We're going to have 0, 0, negative 8, 1, and negative 5, 5. There's my new triangle in blue, and I'm graphing in Google Slides, so sorry if everything isn't looking very precise. I did the best I could. Okay, after this, I'm going to reflect 180 degrees. There's my new coordinates, and you'll notice that I follow those rules for reflection about the origin. And my new triangle graphed here, A double prime, B double prime, C double prime, has coordinates at 0, 0, negative 8, negative 1, and negative 5, negative 5. Okay, we're going to do this again with a quadrilateral, D, E, F, G. And these points are all in quadrant 4. To start with, we're going to reflect in the line x equals 2, rotate 180 degrees, and then translate according to the vector negative 10, 1. Negative 10, negative 1. So here is my original figure. I have D at 9, negative 3, E at 6, negative 7, F at 3, negative 3, and G at 5, negative 1. So my line of reflection, x equals 2, is going to be a vertical line right here. This is going to reflect across that vertical line. Remember that the line of reflection is the perpendicular bisector of segments which connect corresponding vertices from the pre-image to the image. So there are my new coordinates. And there's my newly graphed figure. And it is a little off. My apologies again. It's some bad graphing on my part. D should be right about here instead. So that will make a nice job. Okay, so that's where D ought to be at. Okay, moving on. There's my new figure. This is the 180 degree rotation. And again, my coordinates have changed to their opposites. So I'm going to have kind of a mix here. I have points in quadrants 1, and F double prime is going to be in quadrant 2. So that's what it will look like. And finally, I'm going to translate this according to the vector negative 10, negative 1. So everything is going to be moved 10 units to the left and down 1 unit. We can see the effect of this on my coordinate points, and then I graph the figure here in pink. So that is how you are going to notate your transformations for your figures, remember that capital R means reflection, lowercase r means rotation, and we use the subscripts to tell folks exactly what we want them to be doing with their figures. I hope this has been a helpful video for you on compositions of transformations. Thanks and have a great day.